Functions. What are they? What are they? Functions are a relation from a set of inputs to a set of outputs where each input maps to exactly one output. Why? Functions are the foundation of modern mathematics. Interesting fact: sloths' main predators are jaguars, the harpy eel, and snakes. Now, let's take a look at a function machine so we can get a better idea on what a function is. First, let's talk about what a set is. A set is a collection of numbers, letters, or anything in between. We have two types of sets. The first type is finite, which means there's a limited number of elements in the set. In this example, we have the days of the week. What do we think is the next type of set? That's correct, infinite, which means there's an unlimited number of elements in the set. In this example, we have the integers. Now that we know the different types of sets, let's talk about the first set, which contains the variable x, otherwise known as the input, or the domain, or the independent variable. What do we think are some of the names for the second set? That's right, the variable y, otherwise known as the output, or the range, or the dependent variable. Now, let's dive into the definition of a function by mapping different sets. Only one of these is a function. Which one do we think it is? That's correct, the one on the left. Each input only maps to one output. It doesn't matter if we have letters, symbols, or anything in between. The one on the right, we have two ones in the input set, but each one has a different output, so it is not a function, because in the definition it says each input only maps to one output. Now, let's graph a function to see what it could look like. We have our function y is equal to 2x plus 1. Let's choose our inputs. We have -2, -1, 0, 1, and -2. And the output for each one in order is -3, -1, 1, 3, and 5. Let's combine them to form our ordered pairs. Let's plot the points, let's draw our line, and this graph is a linear function. Linear is one of the many types of functions we could have. We could also have a quadratic function, a cubic function, a square root function, a sine or cosine function, and a step function. Some of these graphs we haven't seen before, but we will eventually. Now, if we encounter a graph we haven't seen before, we can use the vertical line test to determine if the graph represents a function. Remember, each input only maps to one output, so let's draw a vertical line on each graph. Each one passes through exactly one point, so we have one output. It doesn't matter if we move the line to the left, to the right, or back to where we started. Each graph passes the vertical line test. Now, you try. Which one of these graphs passes the vertical line test? That's correct, the graph on the left. The one on the right is not a function because the line passes through the graph twice. And the equation for that graph is y squared is equal to x. And if we solve for y, we get y is equal to plus or minus the square root of x. Let's create an xy table and put in our first point 0, 0. If we draw a vertical line at that point, it does cross only once, but that is the only time. If we move the line to the right, it crosses the graph at 1, 1 and 1, -1. It will continue to cross the graph twice, each time we move the line, whether it's here, or even here. Now, let's take a look at some notation. We have seen y is equal to 2x plus 1, but we can also write it as f of x is equal to 2x plus 1. It doesn't matter if we have a quadratic equation or a square root equation. Instead of y, we can write f of x. So f of x is equal to y. We can read that as a function of x is equal to y. Or we can read that as f of x is equal to y. In other words, the x is the input and the y is the output. We also might see a different variable instead of f, whether it's j, g, h, m, k, or q. It doesn't matter the letter. As long as it passes the definition, then it is a function. These are all functions. Which ones do we recognize? The last bit we're going to talk about is evaluating. Here we have the function 2x plus 1. The input we want to find is 3. So the process is very similar. We still substitute 3 for each x we see. We still multiply 2 and 3, which is 6. So we have 6 plus 1, and the result of that is 7. So we have y is equal to 7, and f of 3 is equal to 7. With f of 3 is equal to 7, we know the input value and the output value immediately. Now, you try when the input is 4. Did you get 9? Awesome. If not, there's always tomorrow. So what are functions?